Hi and Assalamualaikum everyone. I am Tunku Marisa Izati binti Tunku Mama Arzali. I am from 4GK 2023 and I am from SMK Abdurrahman Talib Fountain. So today I will share with you the law of universal gravitation in chapter 3 that is introduced by the Newton's law. So before we get into details, we need to know what is gravitational force. Gravitational force is a universal force because it acts within any two bodies in the universe. So this force is what keeps your body on the ground. For example, as you guys can see in the video, there is sun and also the earth. So have you guys ever wondered why the earth keeps orbiting the sun? This is because there is gravitational force that's acting within the earth and also the sun. Another example of gravitational force is this. My sister drops the powder bottle onto the ground, so the object falls to the ground because of the gravitational force that's acting within the object and also the earth, and that's why the gravitational force will always go down. And what is the effects of the gravity on the human growth? So I will share with you five effects of the gravity on the human growth. And the first one is the difference in density. So during the high gravity, the density of human muscles and bones will increase because the mass increase, and that's why the density will increase. This is because they need more force to move against the resistance. And during the low gravity, the density of human muscle and bone will decrease because they need less force to move against the resistance or maintain the posture. And that's why when we become less dense, we tend to become floating in the air. So, do you know that the previous research has shown that astronauts lose between 1% to 2% of bone density for every month spent in space? And that's kind of terrifying. And the second one is the bone fragility. So during the high gravity, or we call it as hypergravity, there is no significant changes has shown. But during the low gravity, or we call it as microgravity, the bones will become weak and less able to support the body's weight and movement. This is because the bones lose mineral as the density decreases. So when the bones lose a lot of minerals, the density will decreases, and this makes the bone less compact and they become more fragile. So what happens if the bones keeps losing the minerals? So it can lead to a disease called osteoporosis. So as you guys can see in the picture in the left, so there is normal bone, which is they look more compact, and also because of they have a lot of minerals, and also they look more stronger. But for osteoporotic bone at the right, we can see the gaps between them, and because of they lose a lot of minerals and they become more fragile. Alright, next is the size of the lungs. So during the high gravity, the size of the lungs are reduced or contracted because the external pressure compress our lungs. So in our lungs, there will be low pressure, and outside our lungs will be high pressure that will compress our lungs and it will become smaller. So during the low gravity, the size of the lung increases because the pressure inside the body is higher than the surrounding. So inside our lungs there will be higher pressure and outside our lungs will be lower pressure. And that's why our lungs will expand and becomes more bigger. This is another example of size of the lungs. So this is during the low gravity it will become bigger, and during the high gravity it will become smaller, or we call it as shrink. So blood circulatory system. So during the high gravity, the blood collects at the lower parts of the body because of the difficulty to flow upwards. So all the bloods will go to the bottom, and it will be difficult for them to flow upwards back. But during the low gravity, the blood are pushed upwards from legs to head. So this will decrease the amount of blood and fluid in the heart and blood vessels, and that's why um, our face tend to look puffy during the low gravity. This is another example. So, do you know that the astronauts typically experience swelling in the face and head while in space? And this is an example. That is an interesting fact actually, because during the low gravity, our face gonna look more puffy. And the last one is the blood pressure. So during the high gravity, it will have a higher blood pressure because the blood circulates fast, and so more amount of blood will circulate. And also during the low gravity, it will be lower blood pressure because the blood circulation is low, and so less amount of blood will circulate. All right. So, do you know that astronauts experience orthostatic intolerance, which is difficulty to stand due to lightheadedness? So, lightheadedness because of difference in pressure, and that's why it is difficult for them to balance because they have different, you know, balancing in the earth and also in space. So, yeah, that is from me. Thank you.